The next topic I would like to talk about is called short circuit evaluation. It has to do with the logical operators that we spoke about, namely conjunction and disjunction. Okay, only about these two operators. This is more like a second last topic for selection. However, this is not less important than any other topics previously. It's actually a bit more advanced, which requires some in-depth knowledge about the two operators. And the reason that I want to talk about it now is because after you have exposed yourself into writing programs using logical operators in the previous 2 weeks, so now hopefully you got have a better precision to understand what short circuit evaluation really is. We call short circuit evaluation or short circuit effects, either way. Okay, before I do that, I would like to remind you about the most important insight into the two logical operators, okay, conjunction and disjunction. Okay, let me write it down over here. So for conjunction, let's say we got two Boolean conditions, B1 and B2, let's say. So we got B1 with conjunction B2 versus B1 with disjunction B2. Okay, so these are the two logical operators. I want to speak about them together. Okay, let's now remember what's the intuitive insights into these two operations. Okay, each one of them has two. Okay, however, I will mention both of them, but I will only write down one of them, which has direct relevance to the short circuit effects that we're going to talk about. Okay, let's start with the conjunction over here. Okay, we talk about conjunction. The only way to make the conjunction true is when B1 is true and also B2 is true. That's number one, right? But I'm not going to write it down. Okay, so number two insight is, as long as B1 or B2 is actually false, that means the conjunction will just be false. So this is something I'll write it down. Okay, so for conjunction over here, as long as one operand here, either B1 or B2, as long as one operand is false, result of the conjunction is false. Okay, so this is the most important insight you should really know in order to understand the short circuit effects. All right, what about disjunction? It's going to be very symmetric. Okay, for this disjunction over here, we know that the only way to really make the disjunction false is when B1 is actually false and also B2 is false, right? That's the insight I wouldn't write down. However, the second one I will. That has direct relevance to the short circuit effects. And the second one is, as long as B1 is true or B2 is true, the entire disjunction will just be true. Okay, so now I would say, as long as one operand is true, the result of the disjunction is true. All right, so hopefully you have no problem for these two insights. I talked about 4 insights, but I only wrote down 2 of them. Hopefully you have no problem with them. So if you have got any problem, please, you can review the previous lecture more carefully. Otherwise, you just wouldn't understand what short circuit effect is. Okay, having these in mind, I'm going to switch back to the slides, and then we'll go over examples to really see how the short circuit effect can be useful for your programming. Okay, let's go back to short circuit evaluation or short circuit effect. I'm going to use the 2 terms interchangeably. So both logical operators, conjunction and also disjunction, evaluate from left to right. So what it means is, at the runtime, if you got B1 and B2, what a Java runtime would do, they will evaluate B1 and try to see if that's true or false, and then you will evaluate B2 if necessary. So now notice what I said, if necessary. Okay, and then similarly for the disjunction here, it's a binary operation, so I'm going to evaluate the left operand first, and then to see if that's either true or false, and then we'll evaluate B2 on the right if necessary. Again, if necessary, which means it may not. All right, let's now go back over here. Right, it's going to evaluate from left to right. And the operator conjunction here is the short circuit evaluation idea. Okay, so for the conjunction, you will only continue to evaluate the right hand side if so far evaluated true. So what that means is, it's going to go from left to right, meaning that if I know that B1 is already false, do I need to bother with evaluating B2? I don't need to, because if B1 is already false, and then one of the operands is already false, the result will just be false. All right. So now let me put it down over here. So now that means over here, if B1 is already false, means no need to evaluate B2, because the result will be false anyway. Symmetrically, if I know B1 over here in the context of disjunction, if I know that B1 is already true, what does that mean? That means no need to evaluate B2, because if B1 is actually true, so that means one of the operand is simply just true. That means the result will be true anyway. All right. Let me say another way. You will only go ahead to evaluate B2 if B1 is actually true. If B1 is actually true, that means you have a chance for the conjunction to be either true or false, because it depends on what B2 is. Similarly, so now if you know that you will only go ahead to evaluate B2 if B1 is actually false, because when B1 is false, you don't necessarily know the result for the disjunction yet. It really depends on B2 over here, right? You see what I mean? Okay, let me just be more precise over here. Think about this. If B1 is actually true, so that means we should go ahead and evaluate B2. In that case, if B2 happens to be also true, the overall result will just be true. And if B2 happens to be false, in that case, overall result will be false, right? You can see we do need to evaluate B2 in order to know whether the final result should be true or false, right? It's necessary. But if B1 is already false, there's no need to evaluate B2. Symmetrically, if we know B1 is actually false, we do need to evaluate B2, because when B2 is actually true, in that case, false or true is going to be true. In the other case, if B2 happens to be false or false will give you false. So you can see the result really depends on the B2 in this case. So we really need to evaluate B2, right? On the other hand, if B1 is actually true, then you don't need to evaluate B2, right? So really understand what I'm trying to say over here. It's really important for you to get the insight. Okay, let me go back here. Okay, so this example here, you can look at that, but I'm gonna go over another larger example to show you how useful short circuit evaluation or short circuit effect can be. Okay, and similarly, you will only continue to evaluate the right hand side, the second operand for disjunction, if the first operand is actually false, right? I just explained that already on the iPad. All right. Okay, so far I'm just talking about the definition for the short circuit effects, right? You can just go back to what I just said. I summarized many times already, right? Just about the different insights. You may just want to take some notes so you wouldn't forget. All right, so now let's see some example over here, right? I'll just simply switch to my iPad over here and see this. Let's now first of all see the short circuit effect for conjunction. Okay, I'm going to see for conjunction over here. Okay, for conjunction, let's see this. We're going to let the user enter X and let the user enter Y. And then let's see this condition here. That's really important. We want to evaluate this particular condition over here. We want to say if X is not equal to 0 and also Y divided by X is larger than 2. In that case, we're going to print out this particular outcome over here. Otherwise, we're going to actually do this check over here. One thing to note: remember De Morgan that we spoke about, right? I'm just going to mention that very quickly, but you're going to do the exercise yourself. Okay? You can see this will be the if condition over here, meaning that if we go to the else part, that means this condition here is not the case. And then applying De Morgan, you will get a condition like this. It's either that X is equal to 0 or Y divided by X is less than or equal to 2, right? Either way. So that's why over here I'm trying to check either X is equal to 0. In that case, I'm going to say, in that case, you're going to have error because you're going to have the division by 0, like over here, right? And then Otherwise, you're going to say it's not greater than 2, the division, right? Basically, our idea is really to check to see what's really the value for y divided by x. Either it's actually greater than 0, either it's greater than 2, or it's not greater than 2. But if x happen to be 0, it's going to be division by 0 error. That's something we would like to do for this program over here. Okay, that's the overall picture, but you're going to study the program yourself as well in detail to see exactly what's being done over here. Okay, let's see why short circuit effects will be very nice to actually give us the flexibility, not really flexibility, the usefulness about not really running into division by 0 error. Okay, let's try over here. Let's say we got x equal, okay, again, let me just remind you over here, the idea about the program is really trying to see what's the value for y divided by x. Is it larger than 2, or is it smaller than or equal to 2? That's what we want to see. However, you want to be careful every time you do division, x might be 0. So that's the thing we want to be careful. Okay, let's see this. If x happen to be 0, okay, and then y is 10, right? Let's say we have that, right? Let's say x is 0 and also y is 10 from the user. When we evaluate this condition over here, right? Over here, we're going to have x is 0, 0 not equal to 0, and also 10 divided by 0 larger than 2, right? Mathematically speaking, you already see this part over here is undefined because divided by 0. However, remember in programming, we're going to evaluate from left to right. So we wouldn't really run into any trouble as long as we don't really evaluate this explicitly. But we'll see how the short circuit evaluation for conjunction can help us to really guard, to really protect this particular division over here. Let's see. So when we evaluate this here, you can see 0 not equal to 0 is going to be false. According to the short circuit effects, if we'll only continue to evaluate this if this is actually true. But since this is already false, there's no need to really evaluate the right hand side over here. So this will just be unnecessary to evaluate. It's simply unnecessary. Okay. So this is how the short circuit over here really protects about division by 0 error. Okay, I'll let you trace this particular input over here with 5 and 10. I'll let you trace it. Okay, let's do it quickly. Okay, let's now try 5 and 10. Right. By the way, so what's going to be the value? So the value, since we got false and also this part here, simply no need to evaluate. The conjunction will just be false, right? So that means we're going to bypass. So we're still talking about the value for 0 and 10, right? So this part over here, I just explained over here. So the value is going to be false. So we're going to bypass this part over here. And then we're going to execute to see over here, right? And then since x is equal to 0, right? Since we're trying 0 over here, that's going to be true. So this is what we're going to output over here to say division by 0. Right? So that's actually correct. What about this one over here? Let's say we try another input. Let's say 5 and 10. So we got 5 and 10 over here. Okay? So I'm going to say 5 not equal to 0. I'm just doing this condition over here. Okay? So 5 not equal to 0 and also 10 divided by 5 larger than 2, right? So that's what's going to be the result. The result is going to be 5 not equal to 0 is actually true. So for conjunction over here, since this is true, we still need to evaluate this in order to find out what the conjunction should be. So now 10 divided by 5 is 2. 2 larger than 2 is actually false, right? So we know that eventually what we're going to do is we're going to go into this else part over here. I'll let you follow the exact detail for that, right? So this is what's going to be the outcome for the second input over here. All right. I have one more question for you very quickly, and this will actually be discussed somehow, maybe using a slightly different example later. Okay. The question is, what if I suggested something slightly different for this condition over here? As I said before, this part over here, as the first operand for the conjunction. Let me just say that again. So this really protects the division y divided by x, because if x larger than, or if x not equal to 0 is actually false, we wouldn't even get to this part over here because of short circuit effects. But now here's a question for you. Question. Let's say I'll put a star over here. Okay, so star. What if the star is rewritten in the following way by swapping the order of the conjunction? We'd say y not equal to y divided by x larger than 2 and x not equal to 0. So the question is the short circuit effects going to help us in this case? All right, you may want to pause the video before I tell you the answer. All right, assuming that you have thought about it, the answer is, in this case, the short circuit effect is not going to help. The short circuit effects or evaluation would not help. Simply because, remember, short circuit effect is going to evaluate from left to right. So when you evaluate this expression over here, let's say by using 0 and 10. So now you're going to evaluate 10 divided by 0 right away. In that case, you're going to crash. Okay, so it's not going to help. Right? Let me illustrate very quickly about two examples, two input values over here, just to strengthen your understanding. You really want to see how things are working. And then disjunction will be in a very similar manner. Okay, let me switch to Eclipse over here. Let me close this over here. So what I want to see is the short circuit, okay, number 1 over here. So this is the program about using conjunction exactly over here, exactly the same. Okay, let me try first of all. You can see this line number 14 in this case is properly using the short circuit effects, because you can see the first operand here is checking to see if x is not equal to 0. In that case, if it is violated, we can get away from division by 0. All right, let's try that right away. If I click on that, let's say x is, let's say 0 and y is 10. We're going to get error division by 0. Okay, let me just debug that quickly together with you. How about that? Okay, put the breakpoint line number 14 over here and then debug over here. So let's say enter x will be 0 and then y will be 10. Okay, let's switch to the debug perspective, right? Let me also remove the expressions from before. Okay, just do that. Okay, so now we're going to see x not equal to 0. Let's just check this expression over here. It will be false according to short circuit effects. So that means this part over here is going to be false already, so it's not necessary to evaluate the right. We only evaluate the right if the left is actually true. But in this case, it's false, so we don't do that. All right, so now if you try to really go for step over, it's going to bypass 15 and go into this else branch over here. And then since we know x equals 0 is actually true, so that means we're going to step over, and then we'll print out and then say step over division by 0. That's right. That's not crash. Let me show you how things might be done wrongly. If you wrote it wrongly, you wouldn't take advantage of the short circuit effects. Let me do that right away. Go back to Java perspective, and then what I will do is I'm going to give you a second version over here. Okay. Okay, I will put that into comments, and then I would say if, let me put this guy here, the right hand side over here as the left. I swap the order. Put it here, and also I will put this guy here, used to be the first operand to be the second operand. Okay, I would say and then put the opening curly brackets. I would say wrong because okay, let me just say that this one, not taking advantage of short circuit effects to guard or protect the division. All right, meaning that you're gonna do the division right away anyway. So before you can ever check that x is actually not equal to 0, right? Let's try that right away. If I try this, if I say debug over here, all right, again, x will be 0 and y will be 10. Let's switch to debug perspective over here, and then you can see the first one we're gonna even though x not equal to 0 over here, is actually false, but it doesn't matter because it's only going to be there after this one have been evaluated, right? But if you try to evaluate this, you will see. Let me just copy this expression over here. It's the left, right? Remember, from left to right. If I paste it, it's going to be some error, right? So error during the evaluation. To be more precise, if I simply try to step over here, so things will just crash around this expression over here, right? If I say step over, okay, it's going to say exception. Well, every time you got exception, remember we talked about before, exception is like a runtime error. So it's like a division by 0. All right, hopefully you can see. If you want to really use the short circuit effect for guarding or for protecting your expression, the guarding constraint must be on the first operand, like x not equal to 0. Okay, so I'll leave the wrong version over here, but you should really try to compare either this version here that's correct or this version that's not correct. The correct version should always put the guarding protecting constraint as a first operand. Right? I cannot emphasize that enough. Okay, back to Java. Okay, let me now switch back to iPad over here. All right, so I talked about the conjunction case pretty thoroughly. Let's now see the disjunction very quickly, right? Okay, if I switch to disjunction here, another exercise for you to do, okay, if you want to go further about studying the program, compare this program over here and also this program over here. They are equivalents in terms of their outputs. However, one is writing using disjunction over here, and the other one is using conjunction over here. I'll let you compare to see why they should be equivalents. Right? I'll let you compare. But for now, the intended output is the same. We want to know what's really the result for y divided by x. Is it larger than 2? Or is it less than or equal to 2? That's what we want to know. But since we got x over here as the divisor, so we have to watch out for division by 0 error. Okay, but now we're just using the disjunction to help us avoid the division by 0 error. Okay, so here you can see we simply got this condition here. X equal to 0 or y divided by x larger than 2. So this is really the guarding constraint over here. So x equals to, 0. You can think about this as a guarding constraint. For using disjunction. And similarly, let's see this. The x not equal to 0 over here. So when I say protects the division, right? So this is also a guarding constraint. All right, let's now go back to this new disjunction example here. And let's see this. Let's say x is 0, y is 10. 0 and 10. Let's see how it can protect the division. So now what we're going to do is we're going to evaluate this disjunction over here. Let's try. X will be 0. So 0 equals 0 or 10 divided by 0 larger than 2. And we're going to evaluate from left to right. So the left over here first. 0 equals 0 will be just true. And then remember, if it's already true for the disjunction, there's no need to actually evaluate the right-hand side, right? Because the overall result is going to be true anyway. So this is actually not necessary to evaluate. Not necessary to evaluate. And the overall result is just going to be true, right? Because this is true. And now you can see that the arrangement for the branches are slightly different because now we're using disjunction. That's why I said exercise for you. You want to make sure these two programs are actually equivalent. Let me write down the exercise. I think that'll be quite valuable for you to do. Justify yourself this version using disjunction is equivalent to the previous version using conjunction. And the previous version I'm talking about is this version over here using conjunction. All right, let me go back there. So that'll be some highly recommended exercise for you to do, right? So one version using disjunction, the other version using conjunction. Okay, I'll let you do that. Let's go back to this particular example over here. Since we know this this is overall is going to be true, right? So that means we're going to go into checking this condition here. And x equals 0 is actually going to be true. So that means we're going to execute this line over here, right? So that's what we're going to do. All right, so that's the first input. What about the second one? 5 and 10. Okay, 5 and 10 very quickly. So now that means we're still going to start with evaluating this condition over here, right? So now 5 equals 0 or 10 divided by 5 strictly larger than 2, right? You can see y is 10 and x is actually 5, okay? 5 equals 0 is going to be false, meaning that we still have to evaluate this, but it will be safe to do so because guarantee is not equal to 0. So now this will be 2 larger than 2 is going to be false. So overall it's going to be false. If it is false, we're going to bypass the entire branch over here. So we're going to go to the else part, and then it will simply say it's not greater than 2. Okay, so actually that's correct. All right. I think this example here using two versions, one using conjunction and the other one using disjunction, is very valuable for you to get insight about short circuit effects, right? One more insight, one more suggestion to point out, and then we're done with this discussion over here. Remember what I said before. The question was over here. I said for this part over here, what if I change that into this particular condition here by swapping the order? I have the similar question for you. Let's say over here, let me put a star over here, right? The branching condition here. So I would say question, okay? The star over there. What if I swap the order? I'll do this one first. I will do this one first, or this one, swapping the order. So I'm going to get y divided by x larger than 2, or x equals 0. Okay, so now the conclusion will be the same, right? The conclusion will be, in this case over here, x is equal to 0. We're only checking this after this has been evaluated, right? But it's too late. And this part over here, y divided by x is going to be 10 divided by 0, so it will crash first. Okay, you can refer to the Eclipse over here. I'm not going to run again. You can try that for your own good. If you can go to short circuit 2 over here, right? You can see this is the correct version. If you simply swap the order and then try x being 0 for the run, and then you will see it will crash. All right, the same idea for conjunction. All right. Okay, I think that's pretty thorough and complete for the discussion. I will conclude this discussion about short circuit evaluation by one more example, okay, over here. So this is really about a common error I'd like to speak to you about, which I already spoke about, okay. So here, let's now put the conjunction case and also disjunction case together. Let's now just summarize what we know already. So if you look at y divided by x and also y divided by x, so this is really the expression we would like to guard, we would like to protect. So y divided by x and also y divided by x. So this will be the division to protect. To protect or to guard. And we are trying to use in version number 1, conjunction. Version number 2, disjunction. Okay, and then you can see here in version number 1, we are using x not equal to 0. In version number 2, we're using x equal to 0. They are meant to be guarding constraint. Meant to be. Okay. Meant to be guarding constraint. However, are they really guarding the division that they're supposed to protect? The answer is no, because their order is wrong. They are actually appearing as the second operand after conjunction or the second operand after the disjunction. Let's just use one example, and then you'll see the other one as well. That is 0 and 10. So I don't even need to worry about this one here because this one will be evaluated first, right? Always the left must be evaluated. So now y divided by x is going to be 10 divided by 0 is going to be crash right away. Right? You don't even get a chance to go here because you already crashed. Similarly, if you try this disjunction over here, so if you try to evaluate this, 10 divided by 0 also is going to be crash. However, if you swap the order by this moving to the left and this moving to the right, it will do the short circuit effect to protect it, like what we said in the previous example. Similarly, if you try to swap this to be the first operand and this part here to be protected to the second operand after the disjunction, it will also work. Right? Really try to compare the different possibilities. All right, so that's about a short circuit evaluation. It's really important for you to really understand first the definition for logical operators, and then their insights, and then what's going to happen at the runtime. Okay, you can review everything what I have said before you move on.